do. Our first problem, we have parallel stair railings through MN and Q and Q. What is the value of X? So, first thing we have to realize is that we have these parallel things, all of these guys. This is our transversal going through. They gave us the 61 up here at the top. Do we have a relationship between the 61 and the X? Yes, and what is their relationship called? Corresponding. And what is true of corresponding angles? They are congruent. So our X here should be equal to C of 61. Now, what would I write? I'd write these are corresponding angles, so they are congruent, if I got them wrong. Now, how do I know that they are corresponding? Well, if you consider these parallel lines, of course, going on forever, of course, our transversal going on forever, well, the 61 is on the bottom right, the southeastern side, if you will, of the intersection. So is the X, and so that means that they are, in fact, corresponding. Question on number 1. All right, so we move to 2. This time we have a ramp with handrails. Segments AB and DE are parallel to GH. So AB is parallel to DE and GH. So all of those things are parallel to one another. Segments BC and EF are parallel to HJ. So that also means that we have these guys all being parallel to one another. Put these on there. And then, of course, we have our transversals that are the vertical bars that are holding up our railings. So they said if JCB is equal to 115, and they marked that on a diagram for us, which is nice. What is the measure of CBA? So first thing we have to do is figure out what CBA is. CBA. Well, CBA is not one single angle. CBA is a mixture, an addition of this part here and that part there. One of those parts we already know the measure of. Left-hand side or the right-hand side? And what is the value of the left-hand side? 90 degrees. Because we know that this is 90 degrees, so therefore all these parallel things are 90 degrees. So we know that right there we have a 90-degree angle. Now we need to figure out what the measure of E is going to be so that we can add those two together and get my total answer. I already know at this point I can eliminate 2 of my possible answer choices. 1890, because we know it's going to be 90 plus something. What else can I eliminate? 65, because it's at least 90. We know those 2 aren't possible. Alright, so I know we're going to go look at 115 and 155. So now I need to figure out what kind of relationship I can develop about this smaller angle here. Well, I know that it's parallel to this. I know we have various transversally things going on here. So if I look, well, let's see. I know that I have 115 over here. If I look at the guy right next door to it, the same side interior, those two are going to have to add up to what? 180. So 180 minus 115. So 65. And so that means that this guy here is 65. What's this guy over here going to be? 115. So they make a linear pair there. So they have to equal 180. Which means that this guy here is going to be 65. Because that has to equal 180 as well. So my total then is going to be the addition of those two. So 5, 9, 6, make 15. So 155 degrees is that total angle. Lots of stuff to look at for together. Questions? Alright, so we move 3. Good old Sally uses strings to mark a parallel rows for a vegetable garden. Oh, I wonder what happened to 3. Huh. 5 and 3 are missing. Well, then. Number 3, we have the posts of a stairwell. Notice the theme, posts and stairwells. Number 3, what is the value of x? So we have this lovely stairwell thingy going up like this. Yay, beauteous. We know that we have these various railings throughout. We have 150 degrees right there. They want us to find the value of x right here. We can kind of do what we did in the last situation. We said that the posts are parallel, that is good. That means that these guys, the posts, are parallel. Which means we have our transversal cutting through here. And even though mine is not drawn well, that one is parallel too. So what is going to be the relationship between that guy and that guy? And keep in mind, we can ignore all these guys in the middle. So what is the relationship between an angle on the inside here and the angle on the inside here? Same place. Same, I wouldn't say same place necessarily. What do we call that? We basically have this going on. 150 and x. Same side interior. What's true of same side interior? Equal 180 here. Supplementary. So even though we have all these pieces in the middle, doesn't matter. This guy is parallel to this guy to the diagram and the information they gave us. So these two guys are same side interior. So we just need to subtract degrees. Questions? Alright, we go to Sally then, her house. So using strings, mark parallel rows. So the strings apparently have parallel rows. The measure of 1 is 115. What should be the measure of 2? We have 115 there. Basically, the houses are transversal. So is there a relationship between 1 and 2? Are they same side interior again? No, they're not on the interior. Are they corresponding? No, because one's on the left, one's on the right. So we're going to have to do a little bit more work here. We have this guy at 115. Where would the corresponding angle to this guy be? Here? Next to 2. So this one is 115, because those are corresponding. So what must be true of 115 and 2? Supplementary, they make a linear pair. So we all need to do that as subtract digits. So we get another 65er. Last one, we got some pipe here. Cool looking picture. Whoop. 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 Let's see, 45 and x. Two parallel sections. Pipe joint, connected pipe shop. What is 5x? So do we have a relationship between there and there? relationship between this guy and that guy.
Is it same color?
Yep, the same side interior, and what is true of same side interior? Equal 180. So one more time. Subtract. And that was 135.
What's the orange part about it? I don't think there's anything to do like this. Am I supposed to subtract it? You want to do this one? I do that. I don't want to give me my 90. I was like,
Any other questions on those? Alright, please pass that one on. Then we will look at the other one, G through B.
oh, what? Yeah. How you get
G3B, all about parallel and perpendicular. So first of all, they said they want perpendicular. What is true of slopes of perpendicular lines? They're opposites, son. The other thing? Reciprocal, yes.
I want it.
Gotta get it today. So, you need to find situations where the slopes of the lines are both opposite and reciprocal. Now, I noticed that in A, one of them is in slope intercept form, the other one isn't. That's annoying. B, one of them is, the other one isn't. That's annoying. Go to C. Hey, they're both in slope intercept form. Is 4 the opposite reciprocal of 1/3? No. Who cakes? Is, what is the slope on the first one in D? 1. Is 1 the opposite reciprocal of 7? So now we have to actually go through and change them around. They're so neat. So, in A, go ahead and change this guy around. What will be the opposite reciprocal of 2? What? What? 2. Flip over that 2. So, if we get a slope of -1/2 for A in the starting equation, then we will have a perpendicular line. So, let's see if we do. Well, the first thing I'm going to do is subtract 2x to the other side. And then I need to divide by -1. Do I have a -1/2? I have the same number though, so if they're the same, what does that mean about them? Parallel. So that would be a lovely choice for parallel, not so much perpendicular. Alright, so that's A. Now we're going to try B. B, we have a 1/3 as the first slope. What's going to be the opposite reciprocal of 1/3? -3. So we want this slope to be -3 in order to get our perpendicular. It should be, considering it's the only thing left, unless we completely messed up. So we take 3x plus y equals -4. We're going to subtract the 3x. Do I need to do anything else? No. Score. We have an answer. Hallelujah. Question? Item 2 says we have points this and this, which the following pairs points are parallel. We established that parallel means they're going to be the same. So we need to figure out the slope of this original thing, so then we can see which one happens to be the same. So my original one, let's see, I did -4 minus 1. -4 minus 6. That gives me -5 over -10. until we have a final answer of 1/2. So we need to find which of our other slopes is equal to 1/2. So we need to go through each of them until we find 1/2, but I tell you, I'm taking SOL, I'm going to do every single one of them just to make sure. So let's see, this first one I would do 5 minus -2, and then 6 minus -8. So that gives me 7 over 14, and that equals 1/2. I will tell you, if you do the other two, for B, you get a 7/6. C, you get a -6/7. And D, I got 1. So I did check all A to 1. Questions? All right, so 3, we have a graph this time. I will say it was a little difficult to see on the graph where exactly it's crossing on the grid line, which is why a lot of times when you see questions in the actual SOL, they will put dots there. But it turns out that it does intersect here at -5, and it does intersect over there on the x-axis at -2. Because, of course, we need to figure out what the slope of this line is, so that then we can determine what is going to be perpendicular to it. So again, we're going to look for that opposite reciprocal. So its slope here appears to be 1, 2, 3, 4, 5. And 1, 2. Is that the slope of that line? No, why not? Exactly, it's a negative slope. Don't forget about whether or not you have a positive or negative slope. That, of course, will mess you up. So this is actually a -5/2, because we have a line that is declining. Questions about that? So we want something that's perpendicular to -5/2. So what slope are we looking for to be perpendicular to -5/2? Say it. Yeah, positive 2/5. So we need a slope of positive 2/5 from one of the equations. Of course, again, we have to arrange them all so that we can see which one gives us a positive 2/5. So my first one, of course, I'm going to subtract my 5x over to start. And 5 by my -2. That gives me 5/2 x plus 1. Of course, 5/2 is not our goal of 2/5, so we move on. B, so we have 2y minus 5x equals 4. Divide by 2. Wait a second. What? Wait. I'm missing sign or something. Let's try that again. 2y equals -5x plus 4. There we go. So we get y equals -5/2 x plus 2. Well, that's not 2/5 either. So we'll go right away. All right, so we go to C. Try 2x over. And then divide by -5. Oh, hey, we have a one. Found out 2/5. And D, it turns out, you get a slope of -2/5. That turns out to be y equals -2/5 x plus 3. So C is the cup. Questions there? Is the same thing, except now we're looking for a parallel line, and obviously we're starting with a different one. So here I went from the -3 on the y-axis to the 2 on the x. This one is a positive line, which is good. So 1, 2, 3. 1, 2. So we're looking for 3 halves. Parallel, we have the goal of 3 halves. And so once again, we do a bunch of rearranging. For A, when I rearranged it, I got y equal to -2/3 x minus 4. So that, of course, doesn't match. For B, I got y equals -3 halves x minus 2. So matches the 3 halves, but that one's negative, so that doesn't work. C, I got y equals 3 halves x minus 5. So C is my answer. And D is actually 2/3 x. So not so good there. Questions on 4? Last one, they tell us that we have points -8, 5, and 8, -3. They want us to identify the points other than point P with interval coordinates as non-parallel, parallel, blah, blah, blah. What do we need to know here? Well, we of course need to figure out our line, because we want to figure out what is parallel. We need to figure out slope so we can have a slope that is the same. Now, we can of course go to our graph and count, or they did give me some numbers, so I can use that in the slope formula to figure out the slope that I need. So I did -3 minus 5 over 8 plus 8, which gives me -8 over 16, which equals a -1/2. So the slope of that graph is -1/2. And since I'm looking for parallel, I'm going to use that same slope. I need to find -1/2. Now, notice that they want me to go through this point already on the graph. So I'm going to need to count a bunch of -1/2s to figure out which of these points actually works. Now, how do I count -1/2? Well, first thing I would do is start with my traditional method, which is to go down 1 and right 2. And then we can do that again. Down 1, right 2. And down 1 and right 2. But we don't always have to go down. We can start by going up. But if we start by going up, then we need to go left to accommodate the fact that this is negative. So we can start here at -6, and we can go up 1 and left 2, and up 1 and left 2, and up 1 and left 2, and up 1 and left 2, up 1, left 2, up 1, left 2, up 1, left 2. How beautiful is that? So those are all the possible points that happen on a grid mark that could be on our line. So now we just need to check these ones at the bottom to see if any of them, or which ones of them actually work. So the first one is 2, -5. Is 2, -5 one of my values? Yes. Is -9, 1? No. -6, -1? -2, -4? Oops. Oops, but not quite. 0, -4? And last but not least, -4, -2? Yes. There are 4 possible answers there. Write that up. The other thing you need to find is the vocabulary quiz. Hopefully you took a look at that. Some of you did pretty awesome. Some of you
There
The vocabulary quiz needs to get passed up as well. I have written down on the paper.
It will be there. So what, that's like 17 out of 20.
Vocabulary quiz is on 20.
Would it be worse?
Word, did not have your vocabulary cards done last time. Please, please, please get them in a set. It is time to discuss our homework, so if you will locate your homework from that workbook page.
Okay, what did you just say? I did not.
I didn't do it.
Why do you want to fight with that? Paper.
That way you know which one of the original one.
I know, right? That's it, but
Separates.
why does that make you happy?
Alright, so who did we talk about last time? Pythagoras and his glorious theorem. So we have some homework on Pythagoras and his glorious theorem. I see many desks that don't have a Pythagorean theorem marked out. Oh, that's not good. If you are without your homework, then a piece of paper would be appropriate so that you can write down those things that we discussed. Workbook page 203, 115.
Why don't you call me?
I'm gonna smack you one. So the first section of problems there, we needed to figure out the missing side. So use our Pythagorean theorem. Notice that they did tell us that they wanted the answers left in simplest radical form. And so that means, of course, that our answers should be in radicals of decimals for this part. So for 1 through 6, these are the answers I got, except for yours. All right, so we'll review a couple. Wait, is she there? Did not found anything.
You just want me to read it.
Yeah, ready. I've read the answer. There, so 2. All right, what do we want to discuss? Here, 4. Take a look. Number 3. First thing that's weird about number 3 is identifying which parts we have. Of course, we know we have at least one leg. What is the leg? 11. It's definitely one of our legs. Is y another leg, or is that the hypotenuse? That's another leg. Our hypotenuse, of course, across the right angle, so that would be our 61 in this case. So we have our hypotenuse, and then we have another leg in our y. So that means I would have leg squared plus my missing leg squared equal to 61 squared, because that's my hypotenuse. Hypotenuse. Hi, paper. Throw me paper out if you can. So we have 121 plus y squared equals, I don't know what 61 squared is. Very good. So then we need to subtract 121. So let's see, that gets 0, 0, 6, 3. And then we square roots. And so that should get us 60, I believe. Which is the answer they sent, so that makes sense. Folks, you don't have your homework. This should be on your piece of paper. If you don't have a piece of paper, feel free to come get one off the windowsill. Scratch paper works wonders. Definitely shouldn't have a library book out reading. Questions about 3. Should I also mention we definitely shouldn't be napping? Serious. Any other questions on 3? Alright, so now we move to 4. 4 is perhaps a little more difficult because we do have an answer with a radical already in it. So if you missed that one, maybe that's the reason why you weren't necessarily sure how to deal with that square root of 19. Is that square root of 19 a leg or a hypotenuse? This is a leg. Our hypotenuse is what we have over there in y. So we have a leg and we have another leg. So we have a 9 squared. We have a square root of 19 squared, and we are missing our y. So first of all, before we do any actual simplifying here, any questions about 7? All right, what is 9 squared? Now, what happens here? Well, you have a square of a square root. What is the relationship between square root and square? I think somebody said it. They're opposites. They're inverse operations. So one undoes the other one. So what happens when we do this to this? Well, they undo each other. And you're just left with 19. It's actually kind of easier when you have a radical on there because you don't have to do anything. So then we just need to add 81 and 19, which will give us 100. So we keep it at 100. Get our hypotenuse. Other questions on 4?
So every time we end, it'll have a
So sir, let's figure out. So Tiana, open up your book. Let's go. All day. Now, let's talk about number 5, because we like that whole undoes the thingy. 5 isn't quite as simple. Okay? 5 is not as simple because we do actually have to simplify a radical at the end. So let's talk about that. So 5, we have an 8 and an 8 and a y. Those two 8s, what are they? legs. They have to be legs. Because the y hypotenuse always has to be larger than something else, than everything else. And obviously, if those two are the same, they can't be larger. So we have hypotenuse of y. We have our two legs of 8. So I have 8 squared, and I have 8 squared, and I have another y squared. This is number 5, yep. Alright, what is 8 squared? Oh, I have 2 64s. Nice, one of the same number, let's work. 128, alright.
Square y 2
So of course I need 2 square roots, and I get a random decimal, which according to the directions they want it in simplest radical form, not in a random decimal. So we need to figure out how we simplify 128. So does 128, does 4 divide into 128?
Yes.
Okay, what do we get? We take 128 divided by 4. 2, sweet. And of course, 4 is 2 and 2. 4 is 8. That's 2 and 4. That's 2 and 2.
I know.
A lot of 2's. So we need to find all the pairs of 2's. So I have one pair of 2's, another pair of 2's, another pair of 2's, and then I have this poor little 2. You tell me all that. So my 1 is all alone. It's in the square. It has to stay inside the radical. So we'll have 2 on the inside. Now remember, for the pairs, you only put 1, 2 on the outside. So I have 1, 2, 3, 2's. So that means on my outside I have 2 times 2 times 2. That equals what? So that's how I get 8 on radical 2 for my final answer.
Oh, no, but you
2 times 2 times 2.
4 times 2.
Other questions on that? That's the love them radicals. Any other questions? Alright, second section. Woo! We had to identify whether it was right, obtuse, or obtuse.
Huh? You want to write it down too?
I want to do it.
Oh my God. Sorry to hear that. Still need a piece of paper out, or I need to write it and pass to the nurse. Number 11. Nobody likes number 11.
I did good on that one.
Good. Well, let's see. First of all, which one is the largest? 28. So that one has to be squared by itself.
Wait, I thought when the left side is less than the right side that is.
Which have to look for is whether the one that's by only one number is greater than less than or equal.
So you always have to.
So I wouldn't go right versus left. I would look at single number versus the other one. Because depending on how you have it set up. Alright, so we have lots of big numbers here that we need to figure out. So we have 28 squared, 784. 20 squared is 400. 784.
You get 1,000. What? You compare. Yes, that was right. I got that. So
I must have counted wrong.
I got 841.
Yeah, that's what she got up there.
Oh. Now, the question is, and this is what Taryn and I were having a conversation about, which side is bigger?
Oh.
That's the thing that you got to watch out for. Notice that my 841 is bigger. Yes, 841 is bigger. Is that the side that represents the hypotenuse, or is that the side that represents the leg?
The legs.
The legs. Well, we need to figure out what's going on with the hypotenuse. The hypotenuse is smaller. If the hypotenuse side is smaller, that means it is acute.
Oh, no. It's not my fault.
Depends on how you said that.
Aw.
So I said you just got to know it's the hypotenuse side, the one that flags up. All right, so then the question was asked about number 7. Obviously, the largest number there is 10. So, again, it doesn't matter which way you put it. I can put it the other way around. Right, 9 and 64 and 100. And that is what, 73? So since the hypotenuse side is the larger one, that means it is.
I don't have any.
The other one, can you see?
You don't have any.
Okay, make sure you're just comparing, figure out what the hypotenuse side is to the other.
I see that.
Almost. Alright, so we move on. We had a couple word problems there. 13 and 14, of course, are very similar to one another because they're both asking about squares. You might recall we looked at an example of this before we left. Why are we having all this conversation? They're asking for different things, however. You do have to be cognizant of that. 13 says we have a square with a side length of 10. 14 has a diagonal length of 9. So we're looking at different parts there. Preference as to which one we do. All right, then we will do the one that I think is harder, which is number 14. It says we have a diagonal of 9 meters. We have our square. Diagonal is 9. So we need to figure out what the legs are. What is true of our two legs? So that means that I have leg 1 that is going to be the same as leg 2, which should be equal to leg squared. Yeah. And need to put these two together, so we get what? 2L squared equal 81. Divided by 2. Give us 40 and a half. So then we got a square root. What is the square root of 40 and a half?
6.3.
6. Now, and you look up there and you go, that's not the same thing. See, they were trying to trick you a little bit. That's why I think it's the hardest one. This is in meters. So this is meters. And then they gave you the answer in centimeters. Because they're weirdos. So of course, centimeters is just 2 over. So that's where they got 636 centimeters from. Now, of course, 13 is going to be slightly different because in 13, you know that your length of your leg is 10, so you have 10 squared, 10 squared. You're looking for the hypotenuse. Number 13. Yeah, questions on that one? Last one we had was a good old ladder question. So we have the ladder, we have a stone wall. That's exciting. Ladder is 8 feet. Base of the ladder is 5.5 from the wall. About how tall is the wall? Are we looking for a leg or hypotenuse?
Leg.
Leg, yes. The ladder is always the hypotenuse. So, our Miss a leg. We gotta square that. We gotta do that. And so, of course, we gotta simplify all that. So that ends up to 5.8. Questions, concerns, issues. Alright. Let's talk about something else. Right triangles. And 2 is going away right now. But it's going away for this Give me these, man. Somebody right there. You're rude. She really said somebody right there. What are we doing? Today is the day of infamy.
What does that mean?
You said of inmate? Infamy. We now begin the fabulous world.
What is that?
No. You can't do that till next year. Now,
That's not next year.
please understand that trigonometry is a topic within geometry. We will discuss the basics of it. We will merely scratch the surface. You can take a whole semester of trig. And of course, called trig elements functional. But we are merely going to scratch the surface. So what you need to understand is that the reason this whole thing exists is because right triangles are special. Okay? We can solve for everything else in a triangle if we just know 2 things. Did we not just do a problem like this? Where we can find the third side. Yeah. Do we have 2 legs or a leg and hypotenuse? Legs. Okay. So we can do the 12 squared plus the 16 squared and figure out our n squared, so we would know our hypotenuse. Yes. What would we need to do to figure out the missing angle in the second one? Second? Yeah. We know that a whole triangle has what total measures in here? 180. We know we have 90 and 52. We can add those 2 together. Subtract from 180 to figure out what we're missing. Trig allows us to solve something like this, where we have one side and one angle, and we can figure out the relationship between those to find the hypotenuse. Okay, so it now blends the angle world with the side. Dun, dun, dun. So, we can find any of the missing values. We can find all of the values within a triangle using trigonometry. So, here are the trigonometric ratios. First one is called sine. It's abbreviated SIN because it's just too much work to write that actually. You got this little guy here, just write it to 0 with a line across. We'll talk about it in a second. And the sine is equal to the opposite over the hypotenuse. Feel free if you would like to abbreviate that as your choice. Cosine is the next one. We abbreviate that COS. Even harder to write high. We got that little 0 with the slash in it, and it's equal to adjacent over hypotenuse. And then last but not least, we have the tangent, abbreviated tan, which is the opposite over the adjacent. Now you'll notice that there are two pictures there on your paper. What is tricky about trigonometry is that you have different perspectives that you can look from. So first of all, that little zero-looking thing is called theta. Theta is a Greek letter. It is the reference angle. Okay, so that's your perspective. If you're doing any trig problem, you got to pick one of the angles, except the right angle. Okay, the right angle is never a reference angle. Okay, so it's either the leg and the hypotenuse over here, or the leg and the hypotenuse up here. Okay, and so that perspective, that reference angle, changes what works together. So if this is my reference angle up here, of course my hypotenuse always across from the 90-degree angle. What is opposite of this angle?
The opposite.
Opposite, down here. The adjacent, of course, is what is the side, which is right here. But notice, if I move my theta, now the opposite is over here. The adjacent is now down here. Of course, the hypotenuse is always the hypotenuse, so you don't have to worry about trying to find that. So the trickiest part doing any of these problems is identifying where your opposite and your adjacent are so that you can actually solve these problems. The hypotenuse is always in the same place. Questions? So, let's take a look at the problem here. We see our theta, yes? Theta. Where is our hypotenuse? Here's our hypotenuse. Where is our opposite?
The
960 looking thing. Where is the adjacent?
12.
Where's the hypotenuse?
It's 8.
Where's the opposite?
12.
Where's the adjacent? Right over there. See how it moves and changes based on the reference angle? Where's the hypotenuse now? Where's our opposite? Our adjacent? So you've got to be able to identify each of these parts. Where's the hypotenuse? Where's the opposite? Where's the adjacent? Okay, so you got to first start, where's my reference angle? Then you got to look around, see where the opposite, the adjacent are, the hypotenuse, of course, is always going to be across. Question? So, we're going to do a little practice. So, we're going to head out to the hallway.
Oh, you're the one who said that out there.
I'll wait. So, once we get out there, first of all, there are other classes going on, obviously, so let's keep our talking to a minimum. Pay close attention because I'm going to give you various instructions, so you want to be able to make sure.
Last year,
So the goal here, of course, is to get a little practice at finding these different parts. It's not exactly as easy as it might seem to locate which thing goes where. So there are some helps that we have discovered for people. And you'll notice that we have our trigonometric ratios written here with some little acronyms. So please write the acronyms beside your ratios. Those will be very, very helpful. Alright, good.
Know what you mean?
So what we have is SOHCAHTOA. SOHCAHTOA. Sine is your opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So SOHCAHTOA helps you remember what thing you're going to need in order to be successful in solving that particular problem. Questions? Let's stop talking. Let's stop talking. Terrell, stop talking. Now, in order to use the trig ratios, you have to have a calculator that is set in degree mode. That is absolutely essential. Otherwise, you will get every single problem wrong. So, you need to go to the mode button on your calculator. And you need to make sure that on your mode, it has degrees chosen and not radians. Now, if you have a scientific calculator at home, or you're using a scientific calculator on your computer, that is already the case. It's only on your graphing calculators that there is the option of changing that. So you have to have a tech. So you're darkened around degrees. Now, of course, in order to get out of the mode, just press Control. Wait, vote. Yes, your degrees should be darkened.
I just put second. Second. No, it's not. Second.
That's what it's going to be. And then it's fine that. What was that? Orange.
Tommy, you're just talking now, so stop. True? Great. Here's the thing. When you get these calculators, when you go to take your SOL, it will not be in degree mode, I can guarantee that. Because the calculators have to be reset prior to testing so that there is nothing left on it. So, we need to have some people in this room to volunteer to be the reminders of everybody else. Because I cannot, a proctor cannot say to you, make sure your calculator is in degree mode. But if you remind each other, we're okay. So, who is going to be loud and going to be emphatic about putting their calculator in degree mode? We have 3 people up here. Isaiah, great. I think we are covered. Yes.
You said before the SOL?
Hello, how about we stop talking and we get through this? So, whenever you walk into the room to take the SOL, as you are putting your things to the side and you're sitting down, say to everyone around you, make sure your calculator's in degree mode, make sure your calculator's in degree mode, don't forget about degree mode, change your calculator to degree mode.
Ooh, I like that.
Because that is extremely important. Otherwise, you'll miss every single problem, and that's not cool. Yes, sir.
question, when you're calculating degree mode, does it affect any other
It does not.
calculations you might do?
Nope, it'll only affect one answer to get the sine, cosine, and tangent. Yes, sir.
What's radian for that?
Radian is the, what I want to say, the pi-based way that sine, cosine, and tangent are dealt with, which is something that you will discuss if you go ahead and take trigonometry for that semester course, but it's not something that we deal with in geometry.
Oh,
Okay?
trading only a semester course?
Yes. So, let's take a look at an example problem.
I'm like, what?
Numero uno. First thing I would recommend is look at our reference angle. Label what you know. So we have our lovely reference angle of 35 degrees. What is that 12?
I said adjacent.
That is our adjacent. So there's our x. What is the x?
Opposite.
So we have our reference angle. Opposite to it is our x. Right beside it is our 12. So our problem is using an opposite and adjacent. Which of our trig ratios uses opposite and adjacent? Tangent. So we now need to solve, of course, for our x, which is the opposite. So we have our tangent of 35 degrees, which is going to be equal to our opposite, which is our missing value, over 12. So that is the equation that we will use to solve. All other equation solving processes apply. So if I want to get this x by itself, what do I need to do to get rid of that 12? Multiply by 12. So I'm going to multiply by 12 on both sides. And that will give me my value of x. So now I need to go to the beautiful calculating device. I need to type in 12, tan, 35.
Oh.
You see the little tan button there, right? Right above the numbers.
What?
Oh, 12, tan button, and then 35.
What the fuck?
What do we get?
I'm great. Oh, I pressed second.
What do we get?
8.4.
What do the directions tell us we need to round to? The nearest hundredth. So what do we get? 8.40.
Oh, sorry, what would it do on the
What? It will not give you 8.40. And it will probably give you a domain error because 35 would not be a value you would enter. Questions about the solving process? Hundreds.
5.8.
Oh, you write it down. Okay.
Oh.
All right, so let's go to number 2. All right, so we have our 40 degrees up top. First thing I always look at, quite honestly, is whether or not the hypotenuse is involved. Because I know the hypotenuse is always across my right angle. So I look at my right angle, I go across, is the hypotenuse involved? Yes. That's my x. So now I need to go to my 40. I see an 18 over here. How are the 40 and 18 related to one another? They're opposite. So which of our trig ratios uses an O and an H? Our sine object. So we're using our SOL. So our reference angle is 40, so we're going to look for the sine of 40. We want the opposites over the hypotenuse. And our hypotenuse is x in this case. Questions about the equation? Now, how are we going to solve this then? Well, I'll tell you, this is actually a two-step process. We see that x, it's in the denominator, unfortunately. So the first thing that we're going to need to do is multiply by x so we can get it out of the denominator. But now it's attached to a sine 40. What do I need to do with that sine 40? Need it on the other side by what operation? Distributive is not an operation. Not subtraction. There's not a plus sign. It's divide. Yep. Because that x is now multiplied by sine 40. We want to get rid of it, divide it over on the other side. Now, before you attempt to type this in the calculator, this is a situation where you need to use some parentheses. Okay? So certainly type in 18 divided, but then hit your parentheses button so that you have parentheses around your sine 40. What? What? Oh, I see now.
It's 11.57.
Oh, I got it right. What? Listen, that's what you did. Oh, they both got it right.
You got it right.
Y'all talking about what?
Oh, that's the 8. Questions?
No. Yes.
You're supposed to have when you go home. I don't know why we're wrong. Questions? Then try number 3.
Why is trigonometry? So anything that has to do with triangles, we learn about geometry. I hate trigonometry. What do we after school first?
Hey, we have the hypotenuse.
We do have a hypotenuse. What else do we have?
Jason, yep.
So what are we using? Call in our cosine.
I can do it now on the calculator. I feel it.
You have to. Mountain there is 100 plates.
Alright, folks, we need to go ahead and end our discussions for today. So we get for our final answer there. Yep, 12.86. I've modified the homework. We're going to do workbook, page 211. Just 1 through 7. Make sure you drive. Go on. What point?
Oh, they guard rules? So, why is it?
Don't worry about it. No, I'm just saying, like,
Do you guys do anything with the hole punch papers? Like, do we need to do one? Or are we still on the old one?
Everybody have our workbook? Everybody put your calculator away. We don't want to have to wait for everybody.
oh, you like chocolate so bad. Thank you.
Are we singing? Are we ready to go? Alright guys, thanks for your hard work today. See you on yeah, just go see them now, and then they can write you past the class. That would be, I think, a lot easier for you than trying to.
Because we're trying to get my stuff situated, so
Right.
I can either graduate early or graduate on time,
That makes sense.
which I'm trying to do is graduate early.
I see. I
And
see.
I said I wanted to take my geometry online.
Mhm.
This is a lot easier for me. Instead of, I'm not really good with hands-on and like trying to do notes and stuff like that. I'm not really good with that. When I took it, the geometry class,
Mhm.
I passed with a C.
Gotcha.
I'm hoping that it works out that.
Hopefully. Good luck. Ooh.